Good morning, good afternoon, or good evening. Let me first introduce myself. So my name is Eurico Assunção. I'm AWF Deputy Director, and I'm going to give a brief presentation about additive manufacturing in Europe, focusing on recent results from collaborative projects and development of professional qualifications at the European level, but that are already being rolled out at the international level. So the content of my presentation, I'll go through a very brief introduction about the qualification system that has been created in Europe, that is named what we call the International Additive Manufacturing Qualification System. I'll explain a bit which international metal AM profiles we've developed. I'll talk about the approved AM training centers network. And I'll talk about the training modules for an European master degree curriculum, how to implement the master degree in your university and to be part of the MY network, which is a university network for additive manufacture that we are creating. Then I'll move on to the European skills strategy for additive manufacturing, and I'll finalize giving an overview of recent research and development project results related with additive manufacturing. So a bit of an explanation. So a while back, EWF, with a range as an industrial association, and with a range of partners from industry, from research, from academia, started giving the first steps in the creation of the first international additive manufacturing qualification system for personnel, focusing very much on these 5 key points. The first one was that we, as an European system, but that can be implemented in different countries, it needs to look at national requirements. Then it needs to keep in mind that we are talking about a fast evolving technology like additive manufacture that changes constantly, so we need to have a training program that can easily adapt to those changes. It needs to cover different levels of skills. Let's say these 2 bottom ones are a bit connected, so it needs to address from the operator to the engineer. So it needs to also target professional training, or VET like we call it, in higher education, which is normally associated with academia and universities. And finally, but also very much relevant, it needs to be aligned with industrial requirements. We need to have qualifications and a qualification system that answers the needs and the requirements from industry. As part of that, we also make sure that the qualifications that are developed have a very close connection with the standards that are being developed at ISO and ASTM level. Looking at what has been happening already, so the IMQC was, let's say, the starting point to create a network of training centers across the world. Started in Europe, but is already moving from outside of Europe. And we currently already have identified and developed this following international metal AM professional profiles. So what we call the AM process engineer, an AM supervisor, an AM designer, an AM operator, an AM designer, and close to be released also based on what industry asked for, an AM inspector. Just to give you a bit more information of what's happened and how this has been developed and organized, and keeping in mind, once again, these ones were developing projects funded by the European Commission, like Admire and Claim. One of the first questions we asked industry was, do we need an operator for all the processes, or an operator will have a specific process, metal AM process, it will be dedicated to? And the feedback we got was that yes, the operator will have a specific process. It doesn't mean that an operator cannot operate more than one process, but it means that you will need to get training on the individual process is going to work, being a DAD arc operator, a DAD laser beam operator, or a powder bed fusion laser beam operator. Moving on to the designer, we understood also from feedback from industry that the approach needed to be slightly different. So there's no specific requirement for an AM designer for a specific process, but more for groups of processes. So it's expected that an AM designer for powder bed fusion process cannot deal with design rules for powder bed fusion with laser beam, as well as design rules for powder bed fusion with electron beam. The same thing we see for DAD processes. At the process engineer level, we understood that there's also requirement in terms of specialization for two main reasons. First of all, industry. So if you look at industry, it's not that common to find companies that operate more than one metal AM process. So they will have engineers specialized in that specific process, and to make sure that people go in for training, for qualification, focused on the role they're going to have in their company, it was decided to create for the AM process engineer also specialization based on each individual process. Adding to that, there was also another point for this, which is related to the fact that it's also very unlikely to find training centers or research centers or even universities with the capability and with access to equipment for more than one process. So this, let's say, industrial need actually was also aligned with the training organization need in terms of capability in terms of the access to the equipment and the expertise they had in-house. So that's why the AM process engineer was split in this way. Looking at what we are currently doing, we are in the process of approving AM training centers to create an international AM training center network. So just to clarify, EWF itself, we do not deliver the training. We authorize and accredit training centers and using qualifications developed by us with industry to allow them to use those qualifications in a harmonized way to ensure that they can award diplomas that are recognized at the international level. So if you are interested in becoming one of those training centers, being a professional training center, a university, a company, a machine supplier, we have, let's say, 4 basic steps. So first of all, the application. They need to apply to become an authorized training body and become part of the EWF network. After that application happens, the training body will go through an authorization process based on the defined set of conditions and rules. So we have auditors to do this type of assessment, which will be done at, say, point 3, which is assessment conditions. There will be a document review looking at the scope evaluation, which means pretty much which qualification you want to deliver, the conformity with the AM syllabus, the quality of the facilities, of the trainers, of the training materials, the quality manuals for the organization regarding training. Health and safety aspects will also be assessed. And at the end of it, pretty much we can say that the audit will verify compliance with the AM qualification system rules. And final step, after the assessment is done and the approval of the training centers fulfill all the requirements, the training centers can start delivering the courses in a harmonized way based on international diplomas. We also worked, this, like I said initially, this doesn't focus only on professional training, it goes from professional training to universities training. And we actually are also created an European master degree curriculum to be given by a network of universities. So this means that the university can specialize in their specific process and know-how, give the students some specific modules, but then the student has the capability and the possibility to go to other universities and complement his education in additive manufacturing. Like I mentioned, this started at the European level, but we are now rolling this very much this system for professional training, university training, to outside of Europe. So if you want more information, you can find the information here. You can send us an email, and we can explain a bit more about this. Another important point, which I think is also relevant to emphasize at this stage, is all the qualifications were developed to be industry focused, aligned with standards, to ensure an European harmonization, but also an international harmonization. But they were developed, this qualification, with module structure. It means people can do module 1 by 1 and progress with the different modules to get the qualification, or if not, just do the modules of training. So if you are an applicant, if you want to apply to become an university as part of this network, a university or a training provider, but I'm going to give the example of an university, you can contact us. You need to, first of all, evaluate your strategy and capabilities. you need to evaluate and compare to the harmonized qualification and its capabilities and requirements. Choose the job functions and job activities to include in the master degree. So you need to choose exactly which job functions or activities you want to give your students, and we can support you in this. Choose also the learning outcomes and competence units or modules that you want to implement based on your staff capability, but also based on your equipment availability. Then organize the different competence units into modules, because we have our own module structure, but what we normally see, we see universities adapting 1 or 2 or 3 modules into their own specific module, and we also can assist you in this. Then also, as final step, a master evaluation to check if it's aligned with European international standards. So you need to make sure that the assessment bit that is done at the end of a module or at the end of the degree, the master degree, is done according to a specific set of rules that has been predefined by us during this Admire project that I mentioned before. And at the end, your master is created, and it's an international master because it will allow connection with other universities that are already using the same programs, and you become part of the network, which is very much relevant. Another activity that we are currently doing, supported by the European Commission at the European level, is to develop European skill strategy for additive manufacturing. So this has been done in a project called SAM, and it has focused on several target groups, from education to industry, social actors, but also to citizens, to become a bit more aware of what additive manufacturing is. And finally, to legislators, policymakers, local, regional, and national authorities to support the implementation of additive manufacturing training in different regions of Europe. As the, let's say, 4 main pillars of this strategy, we have a main one, which is to implement the additive manufacturing international qualification system. The second one is to develop a strategy for skills needs, and we already have some bit of more information on this. If you want to hear more about the strategy that is being implemented at the European level, you can reach out to me and I can pass on some more information. Identify and validate skills that are needed for additive manufacturing and for industry related with additive manufacturing. So the objective is not to stop here, it's to do a constant identification and validation of the needed skills to be able to develop training programs to address those skills that are needed. It's related to what I explained in the beginning. Additive manufacturing is a fast evolving technology. I'll give you an example. When we did our first market survey 3 to 4 years ago, metal AM was very much the top priority ahead of any other materials. And what we've seen now in the recent studies, metal AM is still the priority, but polymers AM, it's very close by. So like I said, it changes quite a lot, and we need to be aware, and we need to be able to identify those changes and how they can affect the skills that need to be developed. And finally, we are focusing on amplifying the network of the international AM qualification system. So we want to have an international qualification system that is recognized across the globe. We are working with companies, machine manufacturers, to ensure that we reach that level, and we are more than happy in working with organizations also from Brazil to make sure that we do have an international scope, and we do work as a network to make sure that additive manufacturing increases its implementation in industry. As part of this, we will be running, we have a strategy for identifying skills and update professional profiles and qualifications based on what we call 3 possible scenarios. This identification is being done by a structured platform that we call the EMA Observatory, which is pretty much a group of people supported by industry, by qualification partners, university research centers, machine manufacturers, to identify what is needed in what we call real case scenarios in terms of skills for the next 6 months, what is needed in terms of short-term scenarios for the next 2 years, and what will be the needs for industry related to the AM for the next 10 years. So this is what we are trying to do to make sure that we have a methodology and a structure in place capable of dealing with whatever skills are required to be developed for industry related with additive manufacturing. So just to give you a bit of information on how we work, so we have what we call an observatory, which is pretty much an interactive platform, but we're also a group of people in working groups and councils and boards that get data from awareness, AM research, AM projects, AM database information. We also we also have a network of organizations that work with us that keep feeding information about what is needed, and we will be roll out sets of information, so set of data tracking schemes to understand what students, job seekers, and trainers and trainees are looking for related to additive manufacturing. That they got a job, which training they want to do after, those type of information. We will have a methodology that we're already using to measure skills needs in AM. We'll support implementation of the qualification system, and we'll also provide and develop and feed a set of data to update AM profiles as industry evolves in additive manufacturing. Picking up on this and jumping to the next topic, I'm going to also give you a bit of a view, moving, let's say, from the qualification activities and training activities that European has been pushing very hard for the last 3 to 4 years, and now more at the international level also. I'm going to give you a bit of information about some activity in terms of AM research and AM research projects funded by the European Commission, and these are just some examples for you to get a bit of an idea of what European Commission is funding and what research organizations are developing in additive manufacturing. So I'm going to talk about 3 projects. There are many more, but this gives you a very good overview. So I'm going to talk about the AMABLE project, the LightMe, and the Multifund project. Focusing first on the AMABLE project, which is not, we can't really say it's a research project. It's more of creation of a platform to support SMEs that want to get into additive manufacturing. First, go back. SMEs that are not aware of additive manufacturing, SMEs that want to get into the additive manufacturing need some support, but also SMEs that are already using additive manufacturing and want to improve what they are doing with additive manufacturing. So the idea here is to provide support for small and medium enterprises and mid-caps for their individual uptake of additive manufacturing through an ecosystem that provides a wide offering of services. So the idea here is to have a platform with service providers, which are research organizations, external organizations, training organizations, probably in the near future certification organizations that can support SMEs regardless of their maturity level in terms of additive manufacturing in improving what they do in additive manufacturing. So we have a range of products, of services, and they're very much attached to where you are in terms of additive manufacturing. Is it only a rough idea about a product? Then we have services like maturity assessment, implementation roadmap, design. Do you have your first prototype? So we have services here related with visualization, post-processing, simulation, data analytics, finance, robotics, or is your idea ready to go to production? So we have activities here related with industrialization and also quality assurance and parts certification services. So this is the idea here, is to have a range of services that can allow an SME to go from not knowing anything to becoming certified for a specific product or process in additive manufacturing, and go through all the services to get to that level. Some examples. This is a project called ProSat 3D.
Hi, my name is Benjamin. I'm part of the team at Space Structures, which is a Berlin-based space company. Today I would like to show you some cool stuff, however, from the non-space domain. Leg-disabled people use prostheses like the one you can see here. Between the knee hinge and the carbon foot sits an adapter that is quite heavyweight. This adapter weighs around 400 grams and is a real burden in competitive sports, especially when you have to carry 2 of them. That is why we partnered with the Paralympic Sports Club of Berlin to release the lightweighting potential. The result you see here. This adapter comes with 162 grams and is less than half the weight of the original adapter, but with same performance parameters in terms of strength and stiffness. So, how did we do that? We employed mathematical algorithms to remove material where it's not needed and to add where necessary. This is called Topology Optimization. In the end, we had a complex geometry that was brought to life by additive manufacturing. That is a technique in which aluminium powder is melted layer by a laser spot to create the part. So, this part is now sent out for field testing with an athlete. Thanks Amiable for the support to let this project come to life. And thank you for tuning in.
So an interesting example of a company that was supported by Amiable to reach a specific part. I have another one. This was also a project called Active to provide medical assistive devices that supports people in rehabilitation from broken bones and other injuries. And the key challenges were to look at antimicrobial properties with materials, lightweight design, and all of this was another SME that was supported and Amiable for a range of services to get to address these challenges that were identified. Another project that I'm going to talk about is something that we starting seeing more and more happening at the European level, which is creation of services and pilot lines associated with those services. So pilot line, the concept here of pilot line is to have facilities with different processes and different capabilities where companies can come in and try out or develop a specific product or try out a specific technology, or they want to look out to upscale or things like that, their production. So the idea here is to attach a range of services, and in this case, sorry, just going back a bit, in this project LightMe, we actually developed or established 2 additive manufacturing pilot lines. And the idea is to have not just the pilot lines available for companies, but also, let's say, an ecosystem that has a range of services and support activities that can help companies that want to use these pilot lines, from monitoring, testing, modeling, market uptake, innovation management, all of this coming together as a way of supporting companies that want to use these pilot lines. Some examples here. So this is a pilot line with metal wire additive manufacturing that was established to make sure that companies can also use this type of technology, in this case the laser beam, to test specific product ideas or to see if the product can be made in a different way. This is a type of concept. Another one that is also related with additive manufacturing is another pilot line called based on a Borealis machine that was developed in a different project. In this case, with the laser beam with powder. So the idea is to companies that can come in and use these machines as if they want to test something. In this case, we are actually updating the machine to make sure that it has geometric, can also keep track of geometric features of the melting pool and growth of the deposit clad to make sure we have a bit more of a tracking and control system to also to facilitate the usage of these pilot lines by companies. Finally, the last project I'm going to talk about, this is more research focused at some point than probably the other two, or probably the most research focused and the project that I'm going to talk today. So the idea of this project is to look at metal additive manufacturing, powder bed fusion, not really only powder bed fusion, but looking at additive manufacturing, try to tackle 2, let's say, gaps. First of all, normally this mainly looking at powder bed fusion is normally not capable of going beyond single materials. It's a bed full of powder, so what we normally see is one single type of powder in that bed. But also the current range of standard alloys is rather small. So the idea of multi-fun is to overcome these shortcomings by integration of multi-functionalities due to, first of all, novel active materials, but also new structural material using the arc, or most known as WAM. Another objective or target to overcome these shortcomings is also start using multi-material design in geometrically complex 3D parts. So not to go beyond thinking of designing parts for one single material, more to have parts that can be improved in terms of functionality or in terms of characteristics by being designed considering multi-materials. So as a set of objectives, it's a project that has started quite recently. So we have, let's say, 4 main objectives: develop at least 5 new materials customized for AM for manufacturing, with 3 of them using nanotechnology as a way of getting to the right characteristics and properties. Develop also AM equipment and AM software to be able to operate with more than one material. We'll also be testing this with industrial end user cases, also making sure that the materials and the process that has been developed can be used in manufacturing, and we can manufacture physical demonstrators to showcase what this technology can do and how multi-materials can be used in additive manufacturing. And also, it's also very important, we want to make sure that we also have a sustainable product at the end. So we will also be looking at the environmental impact in recyclability and if we can reduce the amount of material used by having multi-material parts. Like I mentioned, so we'll try, first of all, to achieve this objective better. We'll try to maximize the benefits by trying to combine different materials, but also combined with the right AM technology for the position. So we are not limited to a specific process. We are trying to see for a specific material or for a specific part or for a specific combination of materials, which is the best suitable AM technology for that deposition. Just to give you some examples of features that we can start looking at, or we're already looking at, by inclusion also of nanomaterials and multi-materials. So first of all, we are looking at using these nanomaterials included into the material deposited as heat sink materials with the highest thermal conductivity. Also looking at having a high degree of integral design to make possible to embed electrical conductors in complex shaped metal structures, for instance. Addition of sensing and data transfer capabilities to the equipment and software development. And also the integration of tailored optical fibers will enable bridging advanced through sensing capabilities to the manufactured parts to perform structural health monitoring. So we are trying to see how much of this we can do. It's quite challenging, but this is the overall objective. So just as a final conclusion, this was just a range of projects that have been running at the European level at the moment, funded by the European Commission, and just give you an idea of how diverse they are, from qualification development, from master degree development, from training development, to service providing services to SMEs and to industry, to creating pilot lines where industries can come and test their ideas and they can upskill their capability, and finally, but also to develop new materials, improve AM processes, and actually push additive manufacturing forward. I think that's the general objective of all these projects. And with this, I finished my presentation. Thank you very much. If you want to reach out to me regarding any of the presentation I gave and the topics, feel free to do so. Here is my email. Thank you very much, and have a nice conference.